Hi, I'm Chea.
And I'm KIT&CHEIA. We will give you a brief background about spectacle lenses. Spectacle crown glass was a dominant material for spectacle lenses.
Plastic lenses, first Perspex or PMMA, and then CR39 had been introduced.
It was around mid-70s that CR39 began to overtake glass as the material of choice.
This is not to say that glass itself has or will ever totally disappear like plastic lenses. Glass has also evolved, particularly in the area of higher index materials.
The current materials that are famous in this generation are the crown glass, CR39, high index plastics, and the polycarbonate.
Crown glass. Crown glass is a silica-based compound. This glass is a reasonable ophthalmic lens material which is quite heavy and does not have a good impact resistance. It is largely because of these two facts that glass is becoming much less popular.
CR39 is the most common plastic material. Its weight is almost half of the weight of glass, and it has a better impact resistance, and more recent development in scratch resistance coatings have also helped to boost its popularity. Although CR39 has been with us for some time, it was not until the 1970s that it really came into its own. This may, in part, be due to stigma that surrounded plastic. Plastic lenses existed before CR39, but they were made of PMMA and were not of CR39's qualities.
High-index plastics. These materials were developed from CR39. They are generally lighter than CR39, but their main differences are the higher the refractive index and lower Abbe number. There is also a high-index glass, which have a higher than normal refractive index. This means that the lenses had been made thinner, but their material is heavier and it has poor constringence. When combined with a spheric lens from these materials, can make a very attractive lens when compared with a normal spheric toric CR39 lens. As such, they are rapidly replacing CR39 as the plastic material of choice.
Polycarbonate. Although it could be considered as a high-index plastic, polycarbonate deserves to be considered on its own. It is by far the most impact-resistant material. Indeed, it is almost bulletproof. It is used as a ribbing in some bulletproof vests and the bumper bars of modern cars. A better example of the use of polycarbonate in other areas, though, is its use in compact discs. Compact discs, with a requirement for precision, show that polycarbonate is not only strong but of a high quality.
The criteria by which we judge the materials are first, the specific gravity, second, the refractive index, third would be the impact resistance, and lastly, it would be the scratch resistance.
Specific gravity. It enables us to compare the weight of different materials. It is very important to remember that specific gravity is only one factor which affects the weight of the finished lens. A higher refractive index lens may have higher specific gravity, but the reduction in thickness may mean that the finished lens is actually lighter.
Second is the refractive index, which is a significant measure since the higher the refractive index, the thinner the lens can be made because the curves of the lens need not to be as steep.
Impact resistance equip us to evaluate the penetration resistance of common spectacle and safety lenses to high-velocity projectiles, and to examine the current recommendation regarding the use of such lenses.
Fourth is the scratch resistance film or coating that can be applied to optical surfaces.
There are 5 methods in determining the scratch resistance according to International Organization of Standardization. First is the Taylor test.
Second would be the Bayer test,
Third, the steel wall test.
the Tumble test,
And lastly, the eraser test.